trapezium gives a much closer approximation to the area under a curve than a rectangle does. So the trapezoidal rule is a formula that allows us to use a trapezium to find this area under a curve. So on your screen there you can see the trapezoidal rule, and we need to use it to find an approximation for the integral on the bottom there that you can see. So what we need to first do is we're using the formula above, and what we do is we simply can replace the values, the b and the a, with our values that we found. So remember, our 0 is a and our b is 2. So using the formula above, we can approximate by replacing these with those numbers. So 2 minus 0. Then we have the function when it's 0 plus the function when it's 2. So what we get here is we get 0 to the power of 3 plus 1 plus 2 to the power of 3 plus 1. We get a half. 2 minus 0. Oh, I can close that. So 0 to the power of 3 plus 1 is 1. 2 to the cube plus 1 is 9. So if we put that in the calculator, we get 10. So the area, approximate area under this curve between 0 and 2 is 10. Now, we do have something called sub-intervals. It's where instead of doing one big trapezium, we break it up into several smaller trapeziums. And the more sub-intervals we have, the more accurate the estimation will be. So here we have another function and an integral, and we need to find it using 3 sub-intervals. That means there's 3 times we're doing it. So instead of having 1 for log x dx, we're going to break it up into 3 parts. So this neatly comes out as 1, 2 log x dx plus 2 to 3 log x dx, and then last one 3 to 4 log x dx. So in this case, our first integral, so I'll break it up into colors. This one, our middle one will be blue, and our end one will be green, so you can see what's happening. So the first one, we use our trapezium rule, the trapezoidal rule, and we get 2 plus function 1. We then focus on our next ones, and we get 1 over 2 function 3 plus function 2. And then the last one in green, 1 over 2 function 4 plus function 3. So what that turns into, and again I'll do the keep the colors going, we get a half log 2 plus log 1. Then we get a half log 3 plus log 2. And last one, log 4 plus log 3. And that gives us an approximation of 1.8. Here we have one more, this time 4 subintervals. So it's the same kind of thing. We're going to be breaking up our 1 over x squared into 4 parts. So the first one will be 1, 2 dx x squared. Then we have 2 to 3 dx x squared. And now we need to find each of these parts. So the first one turns into a half 1 over 1 squared plus 1 over 2 squared. This next one, we get 1 over 2, 1 over 3 squared plus 1 over 2 squared, 1 over 4 squared plus 1 over 3 squared, and then finally 1 over 4 squared plus 1 over 5 squared. And that comes out as 0.94. So the area under that curve between the interval 1 and 5 is 0.94. So to recap, on your screen you can see the trapezoidal rules. If you need to break it up into subintervals, break it up into subintervals and use the formula as such.